on quadratic transformations. So before we get started, let's just remind ourselves that quadratic, what we're always going to base it off of is this parent or base function of y equals x squared. And when we're transforming it, it's going to have plus or minus a bracket x minus h squared plus k. And that's how we view our transformations. But that is also what we refer to as our vertex form, remember? So our vertex form is when we have that same equation. So when we're in vertex form, f of x equals plus or minus a, x minus h squared plus k, this tells us some information. So first of all, the plus or minus at the beginning is going to tell us about a reflection, and that's going to be a vertical reflection, up and down. Then we have a, which is our vertical stretch, and that tells us how narrow or wide our graph is going to now be. Then we have our h value, and our h value is going to tell us how much it's going to move to the right or the left, our horizontal translation. And our k value tells us our vertical translation, how much it moves up or down. Now, one thing to notice is that our formula, our function says x minus h. So that minus belongs there. So when we're viewing it, we look just at the value. So if you have x minus h, you're moving to the right. X plus h, you're moving to the left. Now, h and k also have other meanings, right? H and k also represent our vertex. And so our x coordinate of our vertex is h, and our y coordinate of our vertex is k. And that's going to be helpful when it comes to plotting a graph and knowing where our vertex now is. So again, what does the h value do? If you input this into your calculator, y equals x squared, you'll get a graph that looks like that. And if you input into your calculator y equals x minus 4 squared, your h value is 4. And what it does is that it moves your graph 4 to the right. So because we still have that subtraction there, we're moving to the right. If we input into our calculator x plus 6 squared, we actually move to the left. So when you have a plus, that means you're moving to the left because your h value is actually negative 6. So the h value is our horizontal shift or translation. How much is it moving from the left to the right? So how do we graph a horizontal shift? We'll start with your parent function, your base function, and move each point left or right. So if we have our parent function here, that's approximately what our graph is going to look like. And if I'm going to apply a horizontal translation of 4, I'm going to move each point 4 to the right. Literally slide them on over, leaving me that. So now my x values have moved 4 to the right, and I have the same y values. I didn't move up or down at all. Only the x values changed. And then if I look at the other version, I move 6 to the left. So there's some points. 6 to the left, 6 to the left, 6 to the left, to the left, and to the left. So all of my points move 6 to the left, giving me my new graph. And if we look at our table right here, I subtracted 6 from my parent function. So negative 2 minus 6 gives me negative 8. Again, my y values didn't change at all. And then when we have our k value, that is we have x squared here, and if we compare it to x squared plus 3, it moves up. If we have x squared minus 2, it moves down. So nothing fancy here. If it is a positive k value, it's going to move up. If it's negative k value, you're going to move down. And so when we look at it, again, you start with your parent function, and you're going to move each point up or down. So my parent function, again, looks like this. It's our base function, y equals x squared. And if I move it up 3, each point up 3, my graph would look like this. And so corresponding, this time my x values all stay the same, but my y values have gone up by 3. All right, so now I have x squared minus 2. So now this time, all of my y values are going to move down by 2. And so my x values stay the same, but my y values have decreased by 2 from my parent function. So if we look here, if we want to describe the transformation of this graph, we have to look at the equation. Now, what is happening? Well, I'm going to move horizontally to the right 2 spaces because it's x minus 2, meaning I'm moving to the right. And then plus 4 means I'm going to go up 4 spaces. So if I have my parent function there, I'm going to move 2 spaces to the right, but also 4 spaces up. So choose a point, like your vertex will help you out here, and you move 2 spaces to the right and then 4 spaces up. And my vertex is, again, this is in vertex form, is 2, 4. Another option to help you graph would be to make a table of values using your transformed equation. Here we've got another one. We've got x plus 2 squared minus 3. Now what's different about this one? Well, I'm going to be horizontally translating 2 to the left because it's x plus 2, so that means my h value is actually negative, so I'm moving to the left by 2, and I'm moving down by 3. So if I start with my parent function, I'm going to move 2 spaces to the left and 3 spaces down. Again, you could graph using a table of values to help you out, but what's the vertex? Well, it's negative 2, negative 3, because once again, x plus 2 means your h value would be negative 2. All right, now we'll move into our plus or minus. So what does the plus or minus do? So we'll try y1 is x squared, and then we'll put a negative in front. So if I graph y1, I've got my normal parabola, and if I just put a negative in front of it, it reflects across the x-axis. This is a vertical reflection. So it's a reflection across the x-axis. What that means is all my y values are becoming negative. So how do we graph a reflection? Well, start with the parent function and then reflect the points over the x-axis. So my parent function here, x equals negative 2, graph my function. And what I'm going to do is I'm going to reflect this across the x-axis. And so all my y values are going to flip. They're going to become negative. Now notice the vertex conveniently stayed the same. Well, and that would be because it's 0. So 0 can't reflect because it's on the line of reflection. But if you notice, my x values stayed the same and my y values changed signs. So I've got negative 2, negative 4, negative 1, negative 1, 0, 0, 1, negative 1, and 2, negative 4. The shape stayed the same, everything like that. It's just that my y values became negative. And then we have the normal a value, and what does that a value do? Well, the a value, if we input it into our calculator, y1 equals x squared, and y2 equals 2x squared. Here's the first one. There we go. It made it slightly skinnier. And then if I put 0.5, it makes it wider. So the a value is a vertical stretch. So if the absolute value of a, so we just look at the number a, if it's bigger than 1, then it's going to make it more narrow. If it's less than 1, so a fraction or decimal, it's going to make it wider than the parent function. So how do we graph a vertical stretch? Is that we sketch the parent function, and then you're going to multiply all the y values by the a value. So here's my parent function. And for the first example, we're going to use 2x squared. So what I'm going to do is I'm going to take that y value when x is equal to negative 2 and multiply it by 2. So that'll give me 8. Same thing for the next one, for the next one, for the next one. Notice that 0, 0 stays the same. So it is a narrower graph. All right, so then for our next one, we've got h of x equals 0.5 x squared. So this time I'm going to multiply all my y values by 0.5. So 4 times 0.5 would give me 2. And 1 times 0.5 would give me 0.5, and so on and so forth. And so when I graph this function, it's going to be wider. It takes longer, essentially, to make it grow. So if we're looking at combining some of these when we describe the transformations of this graph, we start with saying, okay, what's the vertex, just so we know? Well, it's -1, 0, because we have x plus 1, means to have a negative h, and I don't have a k value, so it's 0. So first off, we have a reflection in the x-axis represented by that negative. Then we have a vertical stretch factor, vertical stretch by a factor of 1/4, means I'm going to multiply all my y values by 1/4. Then I have a horizontal shift or translation to the left by 1 space. So to graph this, you have to know which things affect which. So we can reflect first, and then we have to take all those y values once they're reflected and multiply them by 1/4. So they move up by 1/4, and then we shift 1 space to the left. And then also it's important that we're able to write an equation in vertex form when we're given the description. So you always start from your parent function is vertically stretched by, actually you don't always start, but most of the time we'll start from f of x equals x squares is vertically stretched by a factor of 3, translated 4 units to the right and 2 units up. So that means I don't have a reflection, so I don't have a negative. A vertical stretch factor by 3 would be my a value is 3. Translated 4 units to the right would mean x minus 4, right? Because that minus belongs in the formula. So when I move to the right, it's always going to be x minus, and then we move 2 up. From there, you can identify the vertex as being 4, 2. Let's do another one. So if we have a parent function that is vertically stretched by a factor of 1/3, and then translated 2 units to the right and 5 units down, well, my a value is going to be 1/3, my h value is going to be 2, and my k value is going to be -5. So I have 1/3 times x minus 2, because again, moving to the right, squared minus 5. And my vertex would be 2, -5. Again, if we are stretching by a factor of 4/3, translated 2 units to the left now and 5 units down, well, my a value is going to be 4/3. My h value is going to be -2, and my k value is going to be -5. So when I write that in my equation, it looks like 4/3 x plus 2, because I had x minus h, but I put my h is negative, so a negative and a negative makes positive, squared minus 5. And my vertex would be -2, -5. And just for your enjoyment,
it all started when my mom met my dad, and they fell in love, and they had me. Hi, I'm Ryan, and my life, it's kind of crazy.
Here's another one.
It all started when my mom met my dad, and they fell in love, and they had me. Hi, I'm Ryan, and my life, it's kind of crazy.
So go and revisit these if you need some more help with transformations of quadratic functions.